Hello, this is Professor Ramanandan HS, Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. Today's subject is mechatronics with a subject code of 17ME754. So, content of today's presentation are, so far we have been continuously exposed to something called as microprocessor, and immediate previous we have seen what is a microcontroller. So, with a small understanding of those two topics, we will differentiate between microprocessor mu-P and also microcontroller. In short, we call it as mu-C. We use the Greek alphabet mu for micro. So, mu-P and mu-C, microprocessor and microcontroller. So, similarly, we have something called as computer architecture is based on a particular type of design. Something similar to your how do we design the machines. They are based on something, the structure or maybe organization or the ergonomics, the arrangement of things. It depends on certain type of designs or a plan. That also exists in microprocessor, that is called as RISC and CISC. On what basis the microprocessor or the chip is designed. So, it is called as reduced instruction set computing, RISC, or complex instruction set computing. I repeat, reduced instruction set computing or complex instruction set computing. So, we will see what are they. They are just right now you should understand they are the architectural designs. How the we have seen the complete architecture of 8085 microprocessor, Intel microprocessor. So, where the status registers are, where the CPU is arranged, where is the timing and control unit, how the data bus is situated on a line, what is the connection between each and everything. So, they are all well defined, they cannot be abrupt. So, that we call it as architectural design. So, with a feasible design you can reach optimum result. Somehow we plan the house. This should be the hall portion, this should be the rooms, these are the dimension for kitchen, maybe sanitary, all plumbing or tap or electrical wires. So, everything we plan it accordingly so that the things fall rightly into their places. Similarly, in a microprocessor, arrangement has to be placed in right order. So, that is called as RISC and CISC type of architectural designs. So, where should be the microprocessor, where should be the registers, where should be the address bus, where exactly should be the CPU placed, all those things will be depending on two types of architectural designs. We will see what are the differences between those two, and that will be the end of module 2. Later part is module 3, which is called as programmable logic controller. Programmable logic controller, PLC in short. And integration. Integration is nothing but interdisciplinary subjects like hydraulics, being implemented in mechanical engineering, pneumatics, actuators, or maybe integrated systems, say hardwired systems, or maybe CNC where computer is integrated with numerical control, CNC. We will see the interdisciplinary subjects combining together to come out with a technology or come out with an outcome. So, that is called as integration. We are day to day in our life, we are already using them. As upcoming or budding engineers, you should know the basics of whatever is already in utility in the society. So, we will just get exposed to the introduction part of what is called as programmable logic controller. How electronics or a signal controls the entire machine, or maybe the assembly lines, or maybe the robots. How does it do? With the help of just signal and binary instructions. So, we will proceed one by one. So, first thing is differences between microprocessor and microcontroller. You can just go one by one. So, first one is first difference is it is intended to be a general purpose digital computer. So on the other side, it is intended to be a special purpose digital controller. Just observe the differences. It is a general purpose, it is a special purpose. So here is just a computer, here it is computer enhanced with controlling. So controller. So what do you mean by this? Just recall the understanding of microprocessor and microcontroller. So take an example. So we will just say, okay, mu-c. It is just your single chip, okay, single material built on a chip or a CPU built on a chip. So it has only few things, only an internal memory, okay, along with that it will have some computing system. Other than that, it will not have any type of peripheral devices, maybe input giving device or output displaying devices are not there. As well as it has to be given with a clock, okay, there will not be any timer. So it is just a chip which will help in processing, it is just a processor, okay. So that is why it is called as a general purpose digital computer, where it needs to be enhanced to next level. So it can just be used for only the processing, okay, only for calculation of the information or analysis of the information. Whereas on the other side, so it is a special purpose digital controller, okay. Microcontroller can be used for controlling a system, okay. Controlling is an advanced technique when compared to microprocessor. So you might have used the, okay, your mobile phones, okay, or maybe a engine control system, okay, cruise controlled vehicles, where we usually use microcontroller, automatic transmission, okay. So manual transmission is nothing but with the help of human intervention. I am usually giving the inputs, maybe change of gear or maybe application of clutch, okay, along with that the steering geometry. So all these things a human is defining, whereas in cruise control vehicles or in automatic transmission, so okay, if you just change the mode, so you know that vehicle, okay, with a minimum input of a human being, so it performs tasks on its own, okay, it can think and act on its own, okay, it takes the, okay, it can take a turn, so it is accelerated depending upon the, okay, surface of the road, so it changes the gear accordingly depending upon the, okay, torque and power of the engine. So all these things are happening automatically. How does it do? So it is actually controlling the entire vehicle, okay. Similarly, your computer also, it is not just being fed by the input from the, okay, user. So it processes the information, okay. You have something called as in your computer, for example, in a smartphone, so you have, okay, heat dissipation system, where I can relieve the heat from the, okay, from the mobile phones. You have something called as clean master, that is what we usually use to bring the CPU, temperature of CPU to the, okay, optimum temperature, because once the, okay, processor gets heated, so its processing ability will come down, because heat and work are usually relative to each other. So more amount of heat, your work, okay, exponentially comes down. So for that purpose, we will usually prefer the CPU to be at optimum temperature. So controlling all these activities, maybe controlling a temperature or maybe driving a vehicle or maybe application of a brake, okay, without the human intervention, all these things are possible with the help of a microcontroller. So that is why it is called as a digital controller. It is not just a digital processor, it is a digital controller. So this is the first difference. So second difference is, okay, a microprocessor, what does it contain? So it has a CPU, memory, address and interrupt, okay, this is already we know. So come to the microcontroller, it has a CPU, memory, all these things are regular one. That means to say it has a microprocessor, along with that it has timer, okay, parallel and serial, okay, input output controller, along with that internal RAM and ROM. These are the additional peripheral devices. It has a clock or a timer, okay, very important thing. It has input output controllers, say input points or input modules, that is what we call, and output points or output modules. So it has continuous interaction with the system, okay. Microcontroller has a closed loop control system where it can take the input and give the output because of these serial and parallel controllers. Along with that, internal RAM and ROM. So it has memory allocations to store the data as well as to just read the data. RAM and ROM we are already familiar. RAM is nothing but the volatile memory which is usually through which I can just read the information as well as I can write the information to the memory. Memory is also called as location, the location or the space provided to store the data. So volatile memory is RAM. ROM is nothing but the permanent memory which can only be read. Already stored set of data is called as ROM. We have already been exposed to all this. So a microcontroller contains microprocessor. Along with that, it has a timer to control the activities with the form of pulses to control the activity as well as to store the memory, what we call as operand, to store the memory as well as it can read the data stored in the memory also. So all these are the components of MUP and MUSI. Next, coming to something called as OP codes. So I will just highlight the key term to be remembered here. So here it is just a digital computer, it is digital controller. So these are all the contains. What are all the extra things in the components of microcontroller. So the next thing we speak about something called as OP code. It has many OP codes for moving data from external memory to CPU. It has one or two OP codes. A small hint is given to you here. So for moving data from external memory to CPU. So what do you mean by OP codes? To give you an example, it is called as operational codes. So if you want to perform ANSYS in a computer, or maybe you want to play a game in a computer. So what do? I cannot just switch on the computer and start playing it. The system should have data related to that game. Maybe if you are a player of NFS or Project IGI, or in the engineering task we have AutoCAD, we have ANSYS, we have MATLAB. So many softwares that has to be already installed to a system. So that we call it as operand. That is a stored set of information. Our object is readily available with the data. Instruction, whatever you give, the data should be stored within the computer. If there is no data related to that, how can the computer operate on it? So that is called as OP code. So already stored information will be searched by the computer with the help of address. Address is the specified location given to a data stored in the memory. So with the help of address, the OP code is nothing but it will take off the data from the external memory to the CPU. So that provision is many. In case of a microprocessor, it will have many OP codes, but in microcontroller, since it is specified objective designed controller, it will be having either one or two OP codes for each operations. For each set of operation, it will have one or two OP codes to be very precise and realistic. Next comes the next difference is all about the movement of code, rapid movement. So this is the key word here. So it is concerned with rapid movement of code and data from external address to chip, whereas it is concerned with rapid movement of bits within the chip. So what is the difference here? So here it is the data which is usually traveling, the data getting downloaded from the address to chip is faster, whereas in the microcontroller within the because it is a closed loop control system, as I have already mentioned. So it is a closed loop control system where the movement of data is picked from the microprocessor within the microcontroller for the instruction being given from the input. Say for example, I have to okay, change the steering geometry now. With the help of tie rods of an automobile, okay, I have to take a turn. I have to take a turn of, okay, usually 45 degrees. So instruction is taken from the engine control module, okay, so that the steering or the wheels, the front wheel should make a turn of 45 degrees. That information, okay, about the road banking or maybe the road curve is being fed from the sensor mounted in the front bonnet of the vehicle. Okay, proximity sensor usually senses the distance of the curve, as well as it will feed the information to the engine control module. So that engine control module has a microprocessor. It will take the data from the sensor to the microprocessor. Okay. So that process is called as rapid movement of bits within the chip. So the stored information will give an output to the, okay, microcontroller, and from microcontroller to the steering geometry to take a turn of 45 degrees during the automatic transmission or the cruise controlled vehicles. So that, okay, it can be explained with the help of acceleration also. In the top gear, what should be the acceleration of a vehicle and what is the road distance, which is usually a straight path. So that is also being sensed by the proximity sensor, and according to that information within the microcontroller, information is usually cycled in the way what I have explained so far. So rapid movement of information within the chip, rapid movement of data from address to the chip. That is also a difference between microprocessor and microcontroller. So next is, okay, it has one or two types of bit handling instructions. Okay, as I have already mentioned. Okay, so the movement is from external address to the chip. So requirement of the memory is quite less here. It is something relevant to the previous differences between the microprocessor and microcontroller. Whereas in MUSI, since the movement of data is more rapid within the chip and it needs an immediate and quick response of the microcontroller, okay, that causes the necessity for more number of bit handling instruction. I already told you, immediate response is required in a microcontroller because it is a control system. Control system cannot take more time. It is a real time, okay, response machines. Okay, I repeat, it is a real time response machine. That means to say, within a short span of time, say milliseconds or, okay, just within a second, the action should take place. That means to say you have very small amount of time for the response of a system or for outcome of a system. So that makes, okay, necessity for more bit handling instruction being incorporated in microcontroller. Okay. So next example, okay, last difference is it must have additional parts. This is something relevant to the first difference. Okay, because microprocessor has only a processor. It doesn't has an input taking device or, okay, addresses or maybe display system. All those things should be externally fed. So requirement of hardware is more for MUPI, but a microcontroller is already having, okay, its own input output module as well as timer as well as memory. It can function with a very less or, okay, with no additional parts of, okay, so far required for microcontroller. So these are all the differences between MUPI and MUSI. Okay, next differences between, okay, the RISC and CISC. I told you reduced instruction set computing and complex instruction set computing. So I already mentioned it is the architectural design, two different types of, okay, microprocessor architecture. Okay, usually, okay, if I can just go through one by one. Reduced, the word itself will indicate, okay, it is working with a minimum instruction. Here large number of instructions are required. See, reduced instruction set computing is nothing but instruction cycle. Say if I give you an input, okay, with how many number of cycles the output is coming out of the system. So that is very, okay, less instruction is being fed to the computer, okay, or the microprocessor. It will give the input within a short span of time. That is called as reduced instruction set computing. For example, your IBM laptops or maybe Apple laptops, they use something called as, okay, art ladder diagram type of architectural designs, which comes under, okay, reduced instruction set computing. Your Apple iPhones or maybe IBM laptops, few workstations and servers, they use something called as reduced, okay, instruction set computing. So computing comes into picture when you say about okay, basic mathematics. We use a Boolean algebra, okay, we call it as logic and computing, okay, because computer works on logic and computation. Say basic numerology, arithmetic, and if I say structure, there comes the algebra, okay. So all those things are there which needs a more detailing, but right now you should understand reduced set of, okay, reduced instruction set computing means, okay, within a short set of data or instruction, the cycle should be completed. It needs only minimum instruction, okay. Complex instruction set computing is large number of instructions. One more example if you want me to give is, okay, something called as RISC can be adopted in okay, the autopilot running of the aircrafts, where pilot can give only a minimum instruction to the system and the operation take care of the entire things. We call it as fly-by-wire, FBW type of technique. That means to say the instruction is automatically, okay, taken by the system by using of, okay, PLC or programmable logical controller. So that takes care with a minimum intervention of the pilot. The other things are taken care of by the aircraft on its own. So that is called as, okay, reduced instruction set computing, okay. Whereas complex instruction set computing needs more intervention of a human being. He should involve more, give more instruction on, okay, by using his, okay, thinking, as well as the processor also takes, okay, needs more instruction, and it will take more number of cycles to come out for the outcome, okay. Usually we prefer them in supercomputers, okay, supercomputers. So next difference is something related to same thing. This already I have mentioned. Instruction take only one instruction cycle. So it gives you input with a very short span of time because it takes only minimum instruction, its processing speed is more, okay. On the other side, many instructions take multiple instruction cycle because it is being, the system is loaded with so many instruction, so it obviously takes more time for execution. So this is also a complementary point, fixed format instruction, where I give the system input a very fixed format instruction where it cannot vary. So while using RISC type of architectural design, I should be aware of, okay, giving the instruction to the computer for the stored memory. What is the stored memory within the microprocessor? I am able to only get the outcome for only stored set of, okay, fixed format instruction, whereas on the other side it is variable format instruction is possible. That is why we use them in supercomputer and in okay, scientific workstations, okay, for computing a large set of data. And next thing is RISC and CISC difference is it has only few addressing modes, it has more addressing modes. Addressing modes are nothing but, I already told you, it is a specified location from which the data should be collected. The data is stored in the memory. Addressing mode usually goes to more precise set of data where it is available in the memory. So that possibility is only few in case of RISC and many in case of obviously CISC, because it can carry more instruction, it needs more addressing modes, so that to fetch the instruction from a particular memory, its requirement is more, okay. So for example, we call it as direct addressing mode, indirect addressing mode. All these things are not there in a syllabus, but for the sake of understanding, you have status addressing mode, you have register addressing mode. So many addressing modes are there, because when the instruction is given, within a flick of time, it should pick the data from the memory, because memory has a lot of data within it. So that particular information should be fed back to the system output. For that purpose, addressing mode plays a vital role, okay, to reach the place, to pick the object. Because for take an example, in your library, so many books are available. Okay, when you go and approach the librarian, okay, this is the name of the author, this is the name of the book, okay, this is the branch, this is the branch which I study. So obviously he has, okay, allotted the place and the location for particular books of specialized branches with the name of the author in an alphabetical order, okay, with a specific location. So it is easy for him to access. So that is called as addressing mode. Okay. Same thing you can understand with a medical shop also. He will keep the alphabetical order in a specific container. Whenever you go and ask for a particular, okay, pharmaceutical medicine or a tablet, okay, he will pick it very easily because of an orderly arrangement of information of, okay, object what you require, tablet what you require within that container. He would have named it and kept it in a particular order. So similarly, a computer also should be architectured particularly in these two methods. Okay, it needs few addressing modes, whereas the necessity of complex instruction set computing needs, okay, more addressing mode because of more number of instructions. So last point is, okay, due to the symmetrical condition, conditional jumps can be based on bit anywhere in the memory. That means to say, okay, conditional jump is nothing but, okay, whenever you want, okay, more interrupt is available for RISC type of computing, you can take the jump from a regular instruction to the sudden instruction being given to the system. That possibility is more in case of RISC when compared to CISC type of architecture. So that is what we are trying to say here, the differences between all these. So finally, in short, PLC module 3 is nothing but it is a digital electronic device that uses programmable memory to store the instruction, to implement functions such as logic, sequencing, timing, counting. All these things we will study, okay, once we start the module. But right now you should understand, a programmable logic controller is already used in industrial control system, as well as to control the robots, as well as to control the assembly line operations, where I need a precise and accurate control system. Within a short millisecond or nanosecond time, okay, the system should respond. Such machines we call it as real-time response machines. So there I will employ something called as programmable logic controller. So how it is employed? What are the function of a PLC? What are the languages required for PLC? Because it is controlled by computer languages. We call it as ladder diagram, okay, structural flow diagram, or we say it as functional block diagram, FBD, or structure texting, or instruction list. These are all the 5 types of languages which are available. We will see, so what are those languages and how to give the input. So these are the components of the module which are available. So these are the prime objectives of a PLC. It should be rugged in its design to compensate vibration, temperature and noise, interfacing of input and output. Finally, it should be easy for programming. Okay, all these things are the basic information required for understanding a PLC. Hope this content has reached your necessity. Thank you.